Yes, children. Next topic which we have to see is the Williamson synthesis. This is another method for preparation of ether. Okay, Williamson synthesis. This reaction also comes under named reaction. Okay, that is important. In this, we can prepare symmetrical or unsymmetrical ether. By now, you are very much aware with this word symmetrical or unsymmetrical. Ether, you know what is ether? ROR dash, isn't it? When we write down ROR dash. When these two alkyl groups are same, when they are same, you call it as symmetrical ether. When these two alkyl groups are different, then you call it as unsymmetrical ether. So now we are going to prepare this ether. The very important point that you have to keep in mind is here is the alkyl halide and the alkoxides which we are taking. Important thing which to be kept in mind, very important, that whenever you are preparing ether from this by this methods, Williamson synthesis method, alkyl halide should always be primary. It should always be primary. Secondary and tertiary alkyl halides will never give you ether. Instead, they will give you alkene. So the method is alkyl halide. We have taken methyl chloride. This is the primary. When reacts with alkoxide, sodium alkoxide. Alkoxide means alcohol, from the alcohol part one H is removed and sodium has been added. RONA. This Na has sodium and this part is known as alkoxide. Same thing when sodium is attached with the phenyl group here, phenol, instead of from the phenol H is removed and from that Na is added, you call it as sodium phenoxide. Okay. So final product you will always get ether. This ether you will get and the sodium chloride will be as a byproduct. Now here we will see what is the important thing that we have to see, the reaction. Reaction is here, see, here we have taken the primary alkyl halide. Okay, primary alkyl halide has been taken, but the sodium alkoxide that we are taking can be taken as secondary also, tertiary also, primary also, whatever. That taking this part as tertiary or secondary doesn't have any impact on the preparation of ether. Okay, that you have to keep it in mind. So what will happen? Now you can see the reaction. This halides are more electronegative, so it takes the electron from the carbon. This bond has been taken. This carbon develops a positive charge. That means having a carbocation site having the positive charge. So it takes the electron from this oxygen and develops a bonding. So Na leaves out because of this thing not forming a stability bond with this, and this Na gets react with Br, so NaBr is removed and the remaining product will form ether. Okay, is it clear? Now important thing that you have to keep it in mind is that alkyl halide should be primary. Okay, and preparation of ether, otherwise it will give you thus alkene. Why it will give alkene? Because in elimination reaction takes place here. Instead of substitution reaction, elimination reaction will favor it. Here I have given one reaction also. Here you can see that if I will take tertiary alkyl halide and treating with the sodium alkoxide, here I have taken the primary one. So instead of forming this NaBr and this part is getting attached, this will not take place. NaBr no doubt will remove, and along with that the NaBr is removing along with that alcohol, and this alkene will be the byproduct, not ether. This you have to keep it in mind. Similar reaction you can see with phenol. When this phenol is there, hydrogen has been removed. When it reacts with a base, this hydrogen gets react with OH and forms of sodium phenoxide. Sodium phenoxide again reacts with another alkyl halide and forming NaX will be removed, and the final product ether will be obtained, in which one part is with the normal alkyl group, another will be the phenyl group.